Unit 6, Day 5, Property of Logarithms, Part 2. Our learning targets today, you will use the properties to simplify logarithmic expressions, and you will translate between logarithms in any base. Exponential and logarithmic operations undo each other since they are inverse operations. So if we're looking at log with a base b of b to the x power, in the previous lesson we learned that this x we could bring down in front. So we have x times log the base b of b. We learned in a previous lesson that when your base and your log match, it equals 1 whole. So 1 times x is x. Therefore, whenever you have log with a base b of b raised to an exponent, it simplifies to whatever your exponent is. In the next example, if we rewrite this using logs, if we think of this as exponential form and rewrite it using a log, we would say b log with a base b of x is equal to log with a base b of x. So this property or rule states that when you have a base raised to a logarithm and that base of that log matches, it's going to equal whatever your log is. So let's simplify each expression. Log with a base 3 of 3, if we used the power property and moved our 11 down in front, we would have 11 times 1, which you can see is just equal to 11 and the exponent. In example 2, we have log with a base 3 of 81. So we want to rewrite 81 as 3 to the 4th power. So now we have log with a base 3 of 3 to the 4th power. So we can see that these match, so it just equals 4. You otherwise could rewrite that as 3 to what power equals 81 is another way to do this problem, which would also be 4. 5 raised to the log with a base 5 of 10. I see that these two numbers match, so my solution is just 10. 2 raised to the log with a base 2, 8x. Again, you can see these two match, so my solution is just 8x. Most calculators calculate logarithms only in base 10 or base e. What if we have a base other than 10? So log with a base b of x is equal to log with the base a of x over log with the base a of b. You can make this a right here any number that you would like. For a is greater than 0 and a is not equal to 1, any base b such that b is greater than 0 and b is not equal to 1. So you can see the examples below. If we have log with a base 4 of 8, I know that 2 can be raised to a power to get 4 and 2 can be raised to a power to get 8. So I'm going to use a base of 2 to simplify that logarithm. 4 and 8, you can also use a common log of 10 to simplify these logarithms. You can pick any number that you'd like. If we use 2 in this first example, we ask ourselves 2 to what power is equal to 8, and we know that's 3. We ask ourselves 2 to what power is equal to 4, and we know that's 2, and we just simplified this logarithm using change of base. In the next one, if we type this into our calculator and we just type the log 8 button and we divide by the log of 4, we get 1.5. The log button on your calculator says log. So let's evaluate a couple more examples. Example number 5 says log with a base 32 of 8. I know that 32 and 8, a base of 2 would work very nicely. So we say log with a base 2 of 8 over log with a base 2 of 32. Then I can easily ask myself 2 to what power equals 8 2 to what power equals 32? I know 2 to the third power equals 8, 2 to the fifth power equals 32, and I am finished. I then know a base of 3 works well with 9 and 27. So log with a base 3 of 27 over log with a base 3 of 9. 3 to the third power is equal to 27. 3 squared is equal to 9. And again, I just simplified this log as 3/2. 8 and 16, a base of 2 would work nicely. Rewrite log with a base 2 of 16 over log with a base 2 of 8. Again, you're asking yourself 2 to what power is equal to 16? And I know that that's 4. 2 to what power is equal to 8? And I know that that's 3. And I just simplified this log to 4/3. You now can complete your worksheet.